Okay, so we have a 3-variable system, 3 equations, 3 unknown quantities, x, y, and z. And the directions for this problem just says solve. So you could do this, really anyway. And as long as you get the correct solution, that would be a credible answer because it doesn't specify how. And that being said, I am going to show the longhand approach, the by hand method, elimination. And then we'll check our answer with the calculator. But as I said, if this were a test question, the answer is the answer. So how you get it is, not to say it's irrelevant, but it's the point of this problem is to get the answer. So anyways, let's do this with elimination. So if we're going to eliminate, you can choose anything initially. Pick a value that's a variable it's easy to work with, but it doesn't really matter what you pick. I'm going to pick the first 2 equations. Because if you look at the first 2 equations, if I were to add these up, I'm already going to get the z's to cancel. So I'm going to go ahead and do that. If I add those up, I get x plus x is 2x. I get 2y plus 3y is 5y. My negative z plus my positive z is gone. And then I get 7 plus 4 is 11. So now that I've made that, and you could have focused on a different variable, x, whatever, I chose z's. Now that I made that decision, I have to eliminate z again. But I have to use a different pair of equations because we want another statement in terms of x and y. So we're going to need to eliminate z again. So we can't use the one we just did, 2 we just did. So how about I use we'll use the top and the bottom. I like the top and the bottom just simply because they're already opposite signs for z. So let's see, if I add x plus 2y minus z, it's not going to cancel right away with that bottom equation. So we're going to have to, if you notice I got a positive 3, I can multiply the top equation by negative 3. And that will give me negative 3x, negative 6y, positive. What am I doing here? Oh, wait a minute. We're not multiplying by negative. That was my whole point, right? I said it's already negative. Multiply it by 3. So 3 times x is 3x, 3 times 2 is 6y plus 6y, 3 times negative z is negative 3z, and then there's 21. So if you add these up, we get x plus 3x is 4x. This is going to be a single y. That cancels, and this is negative 5. So our other equation in terms of x and y is 4x plus y equals negative 5. And again, there's more than one pathway to the answer, right? I chose to eliminate z's initially, so that dictates how I proceed, but you could have, eliminated x's. You could eliminate anything. Just pick values that make sense to you as far as, some values will be easier than others to work with, but it's all amounts to the same thing in the end. Okay, so now I have a 2-variable system that we can solve. And we can eliminate x's or y's. I think I want to focus on the y values because you notice all I got to do is multiply the bottom by negative 5, right? I get the top equation 2x plus 5y equals 11. The bottom equation, if I multiply it by negative 5, I get negative 20x minus 5y equals positive 25. And then I get negative 18x. This is when we add them up. Y's cancel, right? Equals, this is going to be 36, 11 plus 25. So if we divide here, x equals negative 2. Divide by the negative 18. Now that I know what x is, you can pick really any of these 2, but I would just focus on these 2 here without the, with these factors multiplied in. Choose either this equation I have here in black or red, that's a relationship between x and y, and plug in your negative 2. So let's say I plug into the top equation, right? 2 times that negative 2 plus 5y equals 11. We can solve for y by, well, here we've got a negative 4, so we'd add it to the other side. So if you add 4 to 11, you get 15. And then if you divide by the 5, we get y is equal to 3. So I got y is 3, x is negative 2. And that was the solution to that 2-variable system. And now that we have it, we can plug both of these values in to our favorite equation from the original system in order to get z. Right? That was the variable we eliminated. That's the one we'll get last. So it doesn't matter. We'll pick how about I pick the middle equation? Just for whatever reason, there's a positive in front of the z. All right, so x is negative 2 plus 3 times our y, which is 3, plus z equals 4. So let's see, I get this is 3 times 3 is 9, minus 2 is 7. And if you subtract the positive 7 here from 4, you get negative 3. So the solution set is x is negative 2, y is 3, and z is negative 3. So that's doing it by hand. Now, it's beneficial, even if you did do it by hand, to check your answers, right? Especially if you have the calculator. Again, you could just do this from the get-go if it just simply says solve. So in the calculator, notice I already checked this one out. Now, if you have a newer calculator, it's probably, I guess it's better to use the Polysmith. If you have an older calculator, you're not going to have this, so let me know. I can show you a different way to do it. But if you have a newer calculator, apps, Polysmith, that's the 9th option. It's just a more user-friendly version of this matrix option here on the calculator. But second option, simultaneous equation solver. And then here's what we can put in our system. So remember, we had 3 equations and 3 unknowns. 1, 2, 3 equations, x, y, z. 3 equations, 3 unknowns. All this other features don't matter, at least not for this class. We'll leave it normal and leave it floating, but this part won't matter. Just don't change these settings. And then hit next to to enter the system. So I just put these in here to save time for the video. So you plug in 1, you plug in 2 in front of y, negative 1 in front of z, then 7, 1, 3, 1, 4, 1. Just plug in the values in front of each of your variables here so your system matches what we have. Once that's in there, you can hit solve, which is the graph button, and it'll give you that solution set, right? Negative 2 is x, 3 is y, z is negative 3. So 2 different ways to get the answer. Like I said, the test question, if it just simply says solve, doesn't say how, then there's no reason why you can't just use the calculator if that's your preferred method. Okay, hopefully that helps. And if you have any other questions, let me know. Thanks. Bye.